This slide is about turning Hermes experience into job-ready proof. The Nous Research Hermes model family lines up closely with 3 areas employers care about most: AI engineering, agent roles, and open model expertise. As we go, I'll show how those skills map to real responsibilities on the job, and, just as importantly, how to turn your work into a portfolio that clearly demonstrates what you can build, ship, and improve. What employers are really screening for isn't just whether you can use an LLM, but whether you understand the full stack around it: structured prompting, tool use, reliable JSON outputs, RAG grounding with citations, and local deployment trade-offs. Hermes gives us a concrete example of each of these skills in practice, which is exactly why it works so well as a proving ground for real, job-relevant AI engineering. This slide introduces the Hermes model family. Hermes 3 is fine-tuned on Llama 3.1 in 8B, 70B, and 4 of 5B sizes, with strong function calling, multi-turn conversation, and long context performance. Hermes 4.3 builds on Seed OS 36B base, supports up to 512K context, and reaches roughly 70B level quality with far fewer parameters. For job seekers, that matters because Hermes is open, deployable, and well documented for real technical conversations and agent-based demos. Lesson 1 is that prompt conventions are a skill stack, and ChatML is a great example of why that matters in hiring. It lets you keep OpenAI-style endpoint compatibility even when you're using self-hosted models. That means you can switch between hosted APIs and local inference without redesigning your app layer. In practice, showing you understand message formatting and interoperability often lands better in interviews than just explaining transformer theory. This slide shows the core ChatML message architecture: system, user, assistant, and tool. Each role has a distinct purpose in the conversation loop, and strong LLM systems keep those boundaries explicit. In practice, that means building inference wrappers that route, validate, and format each message type cleanly. In interviews, being able to explain and implement that flow is a strong signal that you understand production-ready LLM engineering. Lesson 2. Function calling is one of the strongest signals that an agent should use a tool. First, we define the available tools with JSON schemas, including each function's name, parameters, and types. Then, the model emits a structured call with the function name and arguments. Our inference layer validates that call, routes it to the external function, and finally returns the tool's output back into context so the model can give a grounded response. What Hermes really trains for is practical agent behavior, and that has a clear portfolio implication. It's not just a model to mention on a slide. It's a pattern for showing that you can build agent loops, not just polished chat interfaces. That could mean a research copilot with retrieval and citations, a support agent that calls internal APIs, or an extraction pipeline that returns validated JSON. This portfolio blueprint is about building an agent, not just a chatbot. A research copilot can retrieve documents, synthesize answers, and cite sources with clear tags. A support agent goes further by calling internal APIs, parsing structured responses, and managing multi-turn conversations. And an extraction pipeline turns messy, unstructured text into clean, schema-validated JSON. Together, these examples show practical, production-ready agent patterns. Lesson 3 is that transparency and controllability really matter. Hiring loops now dig past surface-level claims and look for failure modes like malformed tool calls, hallucinated arguments, brittle schema adherence when conditions shift, and retrieval contamination or hidden state drift. It's not enough to say your model supports function calling. You need to show the mitigation engineering around it, how you detect issues, constrain behavior, and recover safely when things go wrong. To move from a demo to a hireable system, you need guardrails, That means retrying malformed tool calls with exponential backoff and degrading gracefully if something still fails. We validate outputs against typed schemas so bad data gets caught early. We also whitelist which tools the model can use at runtime, reducing risk. And finally, we log every decision, tool call, and argument so the system is debuggable and auditable. To discuss post-training credibly, you need training literacy. For Hermes 3, the reported runs span 8B and 70B models on 48 GPUs and 405B on 128, using modified axolotl with extra memory and parallelism handling at the largest scale. You don't need to reproduce these runs, but you should be ready to explain scaling costs, parallelism trade-offs, why batch size and learning rate matter, how post-training recipes affect behavior, and how synthetic data supports fine-tuning. Hermes 4.3 is built for both performance and efficiency. It supports a 512K context window, which makes it well-suited for long-session applications and large document workflows. It also delivers 144,000 tokens per second on average across 24 Psyche nodes, using the distro optimizer, and with a 50% parameter reduction, it reaches 70B class quality at roughly half the parameter count, improving deployment economics and infrastructure awareness. Model choice isn't just a technical question, it's a business decision. In interviews, hiring managers want to hear how you weigh trade-offs. For example, when a smaller self-hosted model with strong tool use may be the better fit than a larger hosted model. The key factors are cost per token at scale, data privacy and compliance needs, and latency, including where the model runs and how it's deployed. This learning path breaks Hermes fluency into 5 practical steps. First, use ChatML formatting. Then, build a lightweight inference wrapper so you can switch between hosted and local backends. Next, add schema-constrained generation with JSON mode and pydantic validation. After that, implement function calling with clear tool schemas, parsing, and retries. Finally, add retrieval with source citations, and evaluate performance across completion, validity, tool accuracy, and recovery. This slide shows the full agent architecture end-to-end. A user query becomes a structured ChatML prompt, which drives LLM inference and ultimately produces the final response. Building a portfolio project around this full stack is especially valuable because it demonstrates the complete workflow: schema design, robust parsing, tool routing, retrieval grounding, and disciplined evaluation, all within a single coherent artifact. For a strong portfolio signal, don't just show the project. Show how it works and how you evaluated it. Include prompt and schema examples, tool definitions with JSON schemas, documented failure cases, metrics, and before and after system prompt improvements. You should also be ready to explain why ChatML compatibility matters, how JSON mode lowers parsing risk, how function calling simplifies orchestration, and how a 512K context window can reshape product design. This slide maps Hermes capabilities directly to likely interview topics and the portfolio artifacts that prove them. For example, ChatML formatting connects to prompt engineering and interoperability, backed by an inference wrapper. JSON-constrained output shows schema design and reliability, while function calling demonstrates tool orchestration. RAG with citations covers retrieval and grounding. Local deployment speaks to cost and privacy, and training report literacy highlights post-training trade-offs through clear technical writing. This career strategy is about using Hermes as a proving ground. First, show open model fluency by working with documented open weights, not just hosted APIs. Second, build local deployment literacy so you can reason about inference cost, privacy, and the right deployment topology. And third, demonstrate real agent building competence by creating systems that are measurable, reliable and robust, not just impressive demos. What separates a hobby demo from something you can actually hire for? It's the engineering around the model. That means retries, fallbacks, and timeout handling when things go wrong, schema validation before anything moves downstream, and evaluation against real failure cases, not just happy paths. It also means clear architecture documentation. In practice, one polished project with explicit trade-offs is far more convincing than broad claims about being passionate about AI. Here are the key takeaways. What turns interviews into offers is mastering the full stack around the model, not just the model itself. Be ready to talk about ChatML, JSON mode, function calling, and RAG, with Hermes as the vehicle. Just as important is engineering judgment, handling failures, validating schemas, and adding logging. And finally, build one polished project with clear architecture, trade-offs, and evaluation results you can defend confidently.